Hey folks, so this is going to be the example video in section 7.5. So in the last section we talked about the restrictions. So if you didn't watch that, go back and rewatch that so that you'll understand what we're doing for the examples. All right, so let's take a look at example number 1 where we're only dealing with the inverse sine function. So this says that we should find the value of each real number if it exists. Just a note here, anytime it talks about finding the value of a real number, this is code for using radians. So just make sure that you recognize that as you're working through your questions, your quizzes, etc. So each real number automatically means that we're going to be working with radians. Now, I've got a little how-to list over here. And the first thing that we want to do is we want to write our inverse normally. And what I mean by that is we're going to be using this concept up here. We understand that this is the way to write an inverse, and this is our old method back here, what we're comfortable with, what we're used to. So we want to write it in the old way. Then we're going to be using the unit circle to find our missing angles. Remember that inverses find angles. So if we're being asked to find an inverse, that means that we are being asked to find an angle. So we're going to use the unit circle to do that. And then lastly, we want to check our restrictions on that to make sure that we're using proper restrictions. Okay, so let's go ahead then and part A. The first thing that we want to do is we want to write it normally. So this is where we're going to have the sine of y is equal to root 3 over 2. Again, this is using those concepts that we talked about in the first video. And then at this point, we want to use our unit circle. So we want to go to the unit circle. And we want to find all of the places where the sine value is equal to root 3 over 2. Well, that's going to occur at 2 spots. I've already marked them here on the unit circle. And those 2 spots are going to occur at pi over 3 and 2 pi over 3. Then the last thing we want to do is we want to make sure that we check our restrictions. Now remember that the sine inverse restrictions are only going to be on the right hand side of the circle. So that means that we're going to throw this one out. We're only going to keep this first quadrant angle here. And so we're going to keep that pi over 3. The angle that we're looking for is pi over 3. All right, come over to part B then. So this time, once again, let's do the exact same concept. So let's write it normally. Look for all of the places where my sine value is equal to a negative 1/2. I've marked that on the circle already, and that's going to occur at 7 pi over 6 and 11 pi over 6. Now, when we check our restrictions on this one, remember 2 things. First of all, remember that my sine inverse is only on the right-hand side of the circle. So that means for sure we're going to throw out this one. However, we need to be careful here. Remember that in our restrictions, let me take you back up to them because they're right here. In our restrictions, we're only allowed to use from negative pi over 2 to positive pi over 2, negative pi over 2 to positive pi over 2. However, when I think about 11 pi over 6, 11 pi over 6 is down here in between 3 pi over 2 and 2 pi. 11 pi over 6 does not meet my restriction. So just a couple of comments. Let's throw out our 7 pi over 6, but we're also going to have to throw out our 11 pi over 6 because that's not a good option either. So we'll throw that one out. And then what we want to do is we want to take our 11 pi over 6 position and rename it into something in here. So we want to use the negative version of the first quadrant name. So that's going to be at negative pi over 6. And there's just another picture of the exact same thing that I was just talking about. All right, let's take a look then at part C. For part C, again, let's go ahead and write it normally. This one is not off of the unit circle, so in my little how-to here, there's no way I can use the unit circle. So one thing that you could do here is you could actually use your calculator, and you could type into your calculator sine inverse, that's going to be second sine, of the square root of 2, and what's going to happen is you'll get an error in your calculator. The reason for that is the value of root 2 is 1.4. And remember that the values of sine and cosine all have to be between -1 and +1. Think about the sine graph. The sine graph, the amplitude is 1. It goes up at its highest point to 1 and down at its lowest point to -1. So I cannot go outside of that range of values. So 1.4 is just simply too big. And so we would say that our angle does not exist here. All right, so now let's go ahead and jump down to example number 2. Little note here, be certain that the number given is in the range. So that was what we were just talking about. 1.4 is just too big. It's not in that range of values. All right, my how-to list is going to be the same for finding these inverse cosines. The difference is that my restriction is different. Now I'm looking at the top half of the circle, which is quadrants 1 and 2. All right, so let's go ahead. Let's write it normally. And we're looking for all of the places where my cosine value is equal to 0. Again, we are working here, it says each real number, so we're working in radians. All of the places where my cosine value is equal to 0 is going to be at pi over 2 and 3 pi over 2. However, since we're only working on the top half of the circle, we want to throw out this one right here. And so pi over 2 is going to be my only solution on this one. All right, for part B, let's start by writing normally. And we want to look for all the places where cosine is equal to 1/2. That is going to occur at pi over 3 and 5 pi over 3. But we're going to throw out the 5 pi over 3 position because inverse cosine is only on the top half of the circle. So that is example number 2. All right, now let's head down. It's going to be a little ways here. Let's head down to example number 3. Now this one, notice that we are working in degrees. And so just keep that in mind. All right, so let's write normally. So it's going to be the tangent of theta is equal to the square root of 3. This is one of those things where you just do this so many times that you accidentally memorize it. So basically, you know that tangent is a positive number in quadrants 1 and 3. And so you know you're looking for a quadrant 1 or 3 angle. However, tangent inverse, you also know, is only on the right side of the circle. So you want to throw out that third quadrant angle. You want to only keep your first and fourth quadrant angles. The other thing is that if you just think about the unit circle, there's only a few values in the unit circle that we use. And so, like, for instance, if I tried my 30-degree spot, tangent, which is the same thing as sine over cosine, would be a 1/2 over root 3 over 2. Well, that does not equal root 3 when I simplify it. If I were to choose the 45 spot, well, again, sine over cosine is going to be root 2 over 2 over root 2 over 2. That value is equal to 1. The tangent is 1 at 45 degrees. So again, that's not root 3. If I try the 60-degree location, that's going to end up being root 3 over 2 divided by 1/2. And if I do the math on that and I divide my fractions as I should, I do get the square root of 3. So then 60 degrees is going to be my location for theta. Let's slide over to part B. So for part B here, first thing, let's write it normally. And at this point, we really haven't memorized our cosecant values. We take it back and we always refer back to the sine values. So if cosecant is equal to negative root 2, then that means the sine is going to be equal to the reciprocal of that, negative 1 over root 2, when simplified as negative root 2 over 2. So here's where we're going to get our unit circle out, and my sine at negative root 2 over 2, where is my sine value, negative root 2 over 2? Well, that's going to occur in the third quadrant and the fourth quadrant, smack dab in the middle. So this is going to be at 225 degrees or 315 degrees. Now again, 225 we're going to throw out because cosecant inverse restrictions are only on the right side of the circle. So throw out the 225. And really, I also need to throw out the 315 because once again, think about the fact that little graph that I showed you where I want everything between negative 90 and positive 90. 315 is way down the line. It's down here in fourth quadrant. So we can't keep it at 315. We do need to rename that as negative 45 degrees. All right, I'm going to stop this video here and then pick up in another example video.